Alright guys, here's another example. Again, same process. We're first going to find the y-intercept. Then we're going to find the zeros. Then we're going to use the end behavior and the zeros to sketch our graph. Y-intercept, you'll notice our function's a little bit different here.
Mr. U, building call 5157. Mr. U, 5157.
We don't have a cubic function in standard form, so we can't just read the d value right away. We have a factored one. So what we're going to do is the y-intercept, where my graph crosses the y-axis, is when x equals 0. I'm just going to plug a 0 in for x. That'll give me negative 2 to the third power is negative 8. Negative 8. Negative 8 just gives me 8. So when x is 0, y is 8. So 2, 4, 6, 8. That's our y-intercept. Now we want to find the zeros. Those are the x-intercepts again. The zeros of my function are now when y equals 0. So we're going to take our function and we're going to set it equal to 0. And we can solve this a number of ways. We can go through and we can cancel stuff out, but you'll notice this is a factored thing, factored function, set equal to 0. We can use our zero product rule. All of this other stuff doesn't really matter, okay? I can take this x minus 2, set that equal to 0. So when x equals 2, this function will equal 0. That is my y-intercept, my x-intercept, excuse me. Notice how I have this raised to the third power, but I only have 1 0. You'd think we would have 3 because of that degree. Just to kind of challenge you a little bit, that 3 could also be referred to as a multiplicity, but you guys don't need to worry about that. Okay, so we just figured out that when x equals 2, my function is crossing the x-axis. So I can go to 2 and put a dot. Now, I want to use the end behavior to figure out what my graph is going to look like. I'm going to notice that I still have an odd power, but now it's a negative. So instead of facing like this, my function is going to flip. It's going to go the other way. It's going to face like this. So what you guys need to know is this is a negative form of a cubic. You flip it to get the positive form of the cubic. You're going to be so good at end behavior by the time we're done here. So now that we know our graph is going to look like that, we can go ahead and sketch it. But I'm not a very good artist. So what I'm going to do is I'm going to get an extra point to help me sketch it. I think, since I know my graph is going to cross here and here, I'm going to pick 1. And I'm going to plug it in there to see what I get. So when x is 1, I'm going to simplify 1 minus 2 is negative 1. Negative 1 to the third power is negative 1. Negative 1. Negative 1 is 1. So when we simplify that, we get the point 1, 1. So it kind of helps a little bit to get that. So we can kind of sketch our curve in there. The more points that you pick, the better graph that you're going to get. Alright, last one. Let's go ahead and graph this one here. Same deal. We're going to find the y-intercept. This one is in standard form, which is fantastic because I know my y-intercept is at the end of my function there. So when x is 0, y is negative 2. If you forget that, again, finding the y-intercept is just whatever you get when you plug a 0 in for x.
Jacob Reitzel to the attendance office, please. Jacob Reitzel, attendance office.
Remember that I'm going by 2's on my y-axis, okay? I'll put a little note there. Next, what we want to do is we want to find the x-intercepts. The x-intercepts are what you get when y is 0. So we're going to take our function and we're going to set it equal to 0. And the only way you guys know how to solve this is to factor. We're going to factor it to figure out those zeros real easily. What I see is I have a cubic function, 4 terms. The only way I know how to factor that is to factor by grouping. I put parentheses around them, and I'm going to factor out what's in common with each set of parentheses. I have an x squared in common there, so that's going to get factored out, and what's left is x plus 2. And then here I'm going to factor out that -1, x plus 2. Combine my terms, x squared minus 1, x plus 2. Okay, oh, I noticed this is a difference of squares. We can factor that a little bit more. Okay, so now I am completely factored. All that I have to do is set each one of those equal to 0, and that'll tell me the x-intercepts. So I'm going to go x plus 1 equals 0, x minus 1 equals 0, x plus 2 equals 0. So at x equals -1, I have an intercept. At x equals 1, I have an intercept. And at x equals -2. So I'm going to go and I'm going to put dots at each one of those points. Okay, so last thing is we want to determine the end behavior. This looks like it's going to be a pretty curvy graph there. Okay? I just want to notice, is my function positive or negative? I look up here and I say, okay, my coefficient in front of x to the third is a positive. So that means my function is going to be shaped something like that. It's going to start down here and end up here. Okay, so we're going to go ahead and just sketch in our graph. Remember, your graphing calculator can help you with this. Okay, you are going to be asked to find the zeros and the y-intercept. So as long as you know how to do this, you can use that graphing calculator to help you get the shape. But we kind of know what about it's going to look. It's going to cross 3 times, so we're going to sketch it in. Oof, and that's kind of a rough sketch there. We would make sure we have more of a crossing there. Okay, so it really helps being able to find the intercept, the zeros, and knowing what your graph is going to look like. All of your graphs, guys, are going to look either like this or more curvy like this. Go ahead and hit pause, rewind, do what you have to do, plan for some more practice in class. Thank you, guys.